For 100 years, humanity has been broadcasting its existence into space. Television signals, radio waves, radar pulses, a sphere of electromagnetic noise, now over 200 light years across, expanding outward at the speed of light. Every civilization within 200 light years knows we're here. And according to one of the most disturbing theories in modern science, that might be the worst thing we've ever done. The dark forest theory says the universe is not empty. It's full of civilizations, hiding, watching, waiting, and eliminating any civilization that makes itself known before it can become a threat. The silence in the sky is not absence, it's strategy. And we just announced ourselves to everyone. Welcome to Void Atlas. I'm your host, and today we're going somewhere genuinely frightening. Not in the science fiction way, not in the hypothetical way. In the way where you understand the logic, you can't find the flaw in it, and you realize it might actually be true. The dark forest theory. The most disturbing proposed solution to the Fermi Paradox. And the one that, if correct, means humanity has been making a catastrophic mistake for the last century. Let me set the scene. The year is 1950. Enrico Fermi, one of the most brilliant physicists of the 20th century, is eating lunch at Los Alamos with colleagues. The conversation turns to the age of the universe, the number of stars, the probability of other intelligent life. And Fermi asks the question that has haunted astrophysics ever since. Where is everybody? It's a simple question. The universe is 13.8 billion years old. It contains 2 trillion galaxies. By almost any calculation, it should be teeming with intelligent life. Civilizations that have had not just thousands, but millions or billions of years head start on us. And yet, silence. No signals, no visitors, no evidence of anyone anywhere. This is the Fermi Paradox, and there are many proposed solutions. Maybe intelligent life is genuinely rare. Maybe civilizations self-destruct before they can communicate. Maybe we're looking in the wrong places, at the wrong frequencies, with the wrong instruments. But there's one solution that is, in my opinion, the most logically rigorous, the most internally consistent, and by far, the most unsettling. The dark forest. The dark forest theory was popularized in its most developed form by the Chinese science fiction author and physicist Liu Cixin in his novel The Dark Forest, published in Chinese in 2008, translated into English and released in 2015. But the underlying logic is not fiction. It's game theory. It's physics. It's the cold mathematics of survival in a universe of finite resources and infinite uncertainty. And it goes like this. Premise 1. Every civilization needs resources to survive and grow. Food, energy, raw materials. Whatever form they take, resources are required. And resources in the universe, while vast, are ultimately finite. Premise 2. Civilizations, if they survive long enough, will grow. They will expand. They will consume more resources over time. This is not a choice. It's a consequence of survival and reproduction at any scale. Premise 3. The universe contains many civilizations. This is the assumption the Fermi Paradox itself begins with. The numbers demand it. Premise 4. You can never be certain of another civilization's intentions. Now stop at premise 4, because this is where the dark forest logic becomes inescapable. Imagine you discover another civilization exists. You know nothing about them. You don't know their values, their history, their relationship to violence, their attitude toward other species. You don't know if they're peaceful or aggressive, expansionist or contained. And crucially, you have no reliable way to find out. You could try to communicate, send a signal, establish contact. But here's the problem. Interstellar distances mean that any communication takes years, decades, or centuries. By the time you receive a response, the civilization that sent it may have changed entirely. Their intentions today tell you nothing about their intentions in 1,000 years. And a civilization capable of interstellar communication is, by definition, a civilization capable of interstellar travel, and therefore, in principle, a civilization capable of reaching you and doing whatever it wants to you. The risk calculation is asymmetric. If you trust a civilization and you're wrong, you're dead. If you don't trust a civilization and you're wrong, if they were actually friendly, you lose a potential ally, but you're still alive. In a universe of survival pressures and resource competition, the rational strategy every time is not to trust. And if you can't trust, if uncertainty about another civilization's intentions is irreducible, then the safest thing is to eliminate the threat before it can threaten you. Not out of malice, not out of aggression, out of pure, cold, game-theoretic logic. This is the cosmic sociology that Liu Cixin articulates in The Dark Forest. Every civilization is a hunter in a dark forest. Every other civilization is a potential threat. You make no sound, you move carefully. And when you detect another hunter, when you find evidence of another civilization, you eliminate it before it can eliminate you. The silence is not because the forest is empty. It's because every hunter in the forest has learned the same lesson. The ones who made noise are gone. And we have been making noise for 100 years. Now, before I go further, I want to be very clear about something. The dark forest theory is a hypothesis. It is not confirmed. It is not scientific consensus. It is one proposed solution to the Fermi Paradox, a thought experiment with a rigorous internal logic, but not an established fact. But the logic is serious. Serious enough that Stephen Hawking, one of the most celebrated physicists in history, publicly warned against actively broadcasting our presence into space on multiple occasions before his death in 2018. Serious enough that many SETI researchers debate whether we should be sending signals at all. Serious enough that it deserves our full, careful attention. So let's take it seriously. Let's walk through the argument step by step. Look at where it might be right, where it might be wrong, and what it would mean if it is right. Start with the first premise. Resources are finite, and civilizations need them to survive. This is essentially a law of physics. Energy, matter, time, all of these are resources, and all of them are finite in any region of space. Even in a universe as large as ours, the principle of scarcity applies locally. Any civilization that wants to expand, to build, to survive, needs resources. And those resources come from somewhere. The second premise, that civilizations grow, is also essentially inescapable on long timescales. Even if a civilization chooses a path of minimal growth, the underlying pressures of biology and self-preservation will push toward expansion on any timescale long enough. And in the context of a 13-billion-year-old universe, the timescales involved are vast. A civilization that existed for 1 billion years and grew even slowly would have extraordinary resource requirements. These two premises together mean that in a universe of many civilizations, resource competition is inevitable, not necessarily immediate, not necessarily violent, but inevitable over sufficient timescales. Now we reach the crux. Premise 4, the irreducibility of uncertainty. Can you ever be certain of another civilization's intentions? The dark forest logic says no. And here's why. Even if a civilization is peaceful today, you cannot know that it will remain peaceful. Even if its leaders are benevolent, they will eventually be replaced. Its values will evolve. Its resource needs will change. Its relationship to other species may shift in ways you cannot predict from a distance of hundreds of light years, across a communication delay of centuries. You receive a signal from a civilization. They seem friendly. They say they come in peace. But who exactly is sending this message? Their government? A faction of it? A group that doesn't represent the majority? How do you know the message accurately represents the civilization's actual intentions? How do you know the civilization sending the message is the same one that will actually make contact decades or centuries later when ships arrive? You don't. You can't. The uncertainty is irreducible. And so the game theory takes over. Let me walk you through the game theory precisely, because I think it's important to understand this is not just an emotional argument, it's a rational calculation. Consider two civilizations, A and B, who have detected each other. Each must make a choice, cooperate or eliminate. Each faces the same uncertainty about the other's intentions. Each knows that if they cooperate and the other eliminates, they die. If they eliminate and the other cooperates, they win. If they both cooperate, they both survive. If they both eliminate simultaneously, there's a conflict. In game theory, this is a prisoner's dilemma. And in a prisoner's dilemma played with irreducible uncertainty, the rational strategy is to defect, to choose the action that doesn't depend on the other player's trustworthiness, to eliminate. The tragedy is that both civilizations, making individually rational choices, might end up in a conflict that neither wanted, and that would have been avoidable if trust were possible. But trust isn't possible. The communication delays, the fundamental inability to verify intentions across interstellar distances, make trust irrational. This is the cold logic at the heart of the dark forest. Now, there are objections to this, important ones, and I want to go through them honestly, because the dark forest theory is not without problems. The first objection is the cooperation problem. Game theory doesn't always lead to mutual defection. Repeated games, established relationships, verifiable commitments, these can enable cooperation even among self-interested actors. On Earth, countries that could destroy each other have maintained peace through deterrence, treaties, and economic interdependence. Could something similar apply in space? Maybe. But notice what those Earth mechanisms require: repeated interaction, shared frameworks, verifiable commitments, and the ability to impose costs for defection. None of these are available in interstellar relations. You can't have repeated games with a civilization hundreds of light years away. You can't verify their commitments in real time. You can't impose costs quickly. The conditions that make cooperation possible in terrestrial game theory don't exist at interstellar distances. The second objection is, why eliminate rather than just hide? If the goal is survival, why not simply become undetectable rather than actively hunting others? This is a good objection, and it leads to a slightly modified version of the dark forest. Not active elimination, but silence and concealment. Civilizations survive by becoming invisible, by using tight beam communication that doesn't leak into space, by not engaging in large-scale industrial processes visible from interstellar distances, by hiding. In this version, the forest is still dark, but the hunters are not necessarily hunting, they're hiding. And any civilization that makes noise by broadcasting is still at risk, not necessarily from a civilization actively seeking to eliminate it, but from any civilization that detects it and decides that eliminating a potential future threat is safer than letting it grow. The third objection is more philosophical. Would any civilization actually choose to eliminate others? Does the dark forest logic hold for civilizations that have survived billions of years and developed ethical frameworks we can't imagine? This is the genuinely hard question. We can construct arguments that a sufficiently enlightened civilization would find ways to cooperate, to build trust, to avoid the trap of mutual suspicion. But we have no basis for assuming that enlightenment always leads to pacifism in conditions of genuine existential uncertainty. Even on Earth, civilizations with sophisticated ethical frameworks have chosen preemptive action when the perceived threat was severe enough. And in the universe, the threats are real. A civilization that grows and expands will eventually impact others. Resource competition at cosmic scales is not a hypothetical. it's physics. Let me now tell you about the arguments against METI, against messaging extraterrestrial intelligence, because this is where the dark forest theory connects directly to decisions humanity is making right now. METI is the practice of intentionally transmitting signals into space in hopes of making contact with other civilizations. It's distinct from SETI, the search for extraterrestrial intelligence, which is passive listening. METI is active broadcasting. The Arecibo message, transmitted in 1974 by the Arecibo radio telescope in Puerto Rico, was an early example. A binary encoded message of 1729 bits, representing information about humanity, Earth, and our solar system, sent toward the globular cluster Messier 13, 25,000 light-years away. It will take 25,000 years to arrive, and any response would take another 25,000 years to return. By most measures, a fairly low-stakes experiment. But more recently, there have been more deliberate, sustained METI efforts. The cosmic call transmissions, sent from the Yevpatoria radar telescope in Crimea in 1999 and 2003, were directed towards specific nearby stars. The A message from Earth project, transmitted from Yevpatoria in 2008, sent digital information toward Gliese 445, a star approximately 17 light-years from Earth. The Beacon in the Galaxy message, proposed by a team including several NASA scientists, was designed as an updated version of the Arecibo message and proposed for transmission in the 2020s. Each of these transmissions adds to the sphere of electromagnetic information spreading outward from Earth, announcing our existence and providing information about where we are and what we're like. Stephen Hawking's response to METI proposals was unambiguous. He argued in multiple venues. His documentary Into the Universe with Stephen Hawking, interviews, and public statements that actively attempting to attract the attention of extraterrestrial civilizations was extraordinarily dangerous. His analogy was direct. It's a little like opening your door and announcing to the forest that you're here. If there are predators in the forest, you've just told them where to find you. Hawking's concern was not the dark forest specifically. He did not endorse Liu Cixin's exact framing. But the underlying logic was the same. We don't know what's out there, we don't know how it would respond to knowing we exist, and the downside risk is catastrophic. A letter signed in 2015 by a large group of scientists and technologists, including Hawking, Elon Musk, and numerous astrophysicists, called for a moratorium on METI pending international discussion and consensus about whether and how to transmit. The letter argued that a decision to actively attract alien attention was a decision that affected all of humanity and should not be made unilaterally by any individual or organization. The debate is ongoing. Proponents of METI argue that the dark forest logic is too pessimistic, that civilizations advanced enough to reach us would likely have moved beyond predatory aggression. They argue that our existing signals have already announced our presence, so being more deliberate about communication doesn't change our situation significantly. And they argue that the potential benefits of contact, scientific knowledge, technological exchange, the discovery that we're not alone, outweigh the hypothetical risks. Both sides have legitimate points. But I want to sit with the skeptical position for a moment, because I think it deserves more attention than it usually gets. The argument that we've already announced ourselves deserves scrutiny. It's true that our radio leakage has been expanding for a century, but there's a difference between passive leakage, television signals, and radar that were not intended for interstellar communication and that weaken rapidly with distance, and directed high-power, information-rich transmissions deliberately aimed at specific star systems. Passive leakage is detectable, but requires significant effort to receive and decode. A civilization at 10 light-years would need a radio telescope far more sensitive than anything we currently possess to detect our television signals reliably. Our deliberate transmissions, by contrast, are significantly more powerful, more information-dense, and more clearly artificial. There's also the matter of what information we provide. Our leakage reveals that technological life exists here. Our deliberate transmissions can tell a potential listener exactly where we are, what our technology level is, what languages we use, and even what we look like. The more specific and information-rich the transmission, the more useful it is to any civilization with unknown intentions. If the dark forest logic is even partially correct, more detailed transmissions are more dangerous than less detailed ones. And if you're going to take a position on this question now, here's why now matters. We're at a particular moment in history where our transmission capabilities are growing dramatically. The next generation of radar and radio systems will be far more powerful than anything we have today. Deliberate high-power METI with current technology is already more impactful than the passive leakage of the 20th century. With future technology, we could send signals detectable at much greater distances to many more stars with much more information content. The decisions we make in the next few decades about whether and how to broadcast will shape our electromagnetic footprint for centuries to come. Now I want to address something that often gets raised in response to the dark forest theory, and that I think deserves a direct answer. The question, isn't this just paranoia? Isn't assuming hostile intent the kind of tribalism we should be trying to move beyond? I understand this objection. It comes from a good place, from the reasonable belief that cooperation is preferable to conflict, and that assuming hostile intent is a self-fulfilling prophecy. But here's the key distinction. The dark forest logic is not about assuming that all civilizations are hostile. It's about recognizing that you cannot assume any civilization is safe, because the uncertainty is fundamental and irreducible. The game-theoretic trap doesn't require most civilizations to be hostile. It only requires enough uncertainty that rational actors choose caution. And in conditions of existential uncertainty, caution means concealment, not communication. This is not tribalism. It's not xenophobia. It's the recognition that under certain game-theoretic conditions, even peaceful agents can find themselves in conflicts because the structure of the game doesn't permit the trust that cooperation requires. And if the dark forest is real, the existence of peaceful civilizations doesn't help us. Those civilizations are hiding too. They're not going to come to our rescue. This is where I want to pause and make sure you're still with me. Because what we're really talking about is one of the most important questions facing humanity, not just intellectually, but practically. The question of whether to broadcast into space is a real question, debated by real scientists and policymakers right now. And the dark forest theory is a real argument in that debate. If you're the kind of person who wants to engage with these questions at this level, subscribe to Void Atlas. Every week we go deep into the things that actually matter, the questions that don't have easy answers. Subscribe and keep coming back. Let me now tell you about what the dark forest implies for our current situation and what, if anything, we can do about it. If the dark forest is true, we are in a very specific situation. We have been broadcasting electromagnetic signals for approximately 100 years. Those signals have expanded outward as a sphere approximately 200 light-years in radius. Within that sphere are thousands of star systems, potentially including systems with planets that could host civilizations. The question is not whether those civilizations know we exist. If the dark forest is correct and capable civilizations exist nearby, they likely already do. The relevant question is, what do they do about it? Several scenarios follow, none of them entirely comfortable. Scenario 1, the dark forest is correct. There are civilizations within 200 light-years, and they have detected our signals. The question then is whether our current technology level represents enough of a threat to warrant elimination, or whether we're so technologically primitive that we can safely be ignored for now. A civilization that has existed for 1,000,000 years, looking at our 100-year-old radio signals and 200-year-old industrial technology, might conclude we're so far behind them that we pose no threat for the foreseeable future. They might choose to wait and see, which means we have a window, potentially a long window, in which continued broadcasting is not immediately dangerous. But that window closes as our technology advances. As we develop space travel, as we begin to exploit resources beyond Earth, as our military and industrial capabilities grow, we start to look less like an ignorable primitive and more like a potential future competitor. Scenario 2. There are no civilizations within 200 light years capable of receiving and acting on our signals, either because life is genuinely rare in our galactic neighborhood, or because any civilizations that exist are so far away that our signals haven't reached them. In this case, the dark forest threat is distant, not zero, but not immediate. Scenario 3. The dark forest theory is wrong. The silence has a different explanation. Civilizations are rare, or they self-destruct, or they evolve beyond the kind of electromagnetic communication we're looking for, or they simply haven't found us yet. Each of these scenarios has different implications for what we should do, and we don't know which one is true. What we do know is that the dark forest argument has enough logical force that it should be part of the conversation when humanity makes decisions about broadcasting. Not necessarily the deciding factor, but part of the conversation. And right now, it often isn't. Here's something that I find genuinely remarkable about the state of this debate. The question of whether humanity should be actively broadcasting its existence into space is, arguably, one of the most consequential decisions our civilization could make. If the dark forest is even partially correct, the wrong decision could have existential consequences. And yet there is no international governance framework for METI, no United Nations body with authority over what signals humanity sends into space, no scientific consensus on what information should or shouldn't be transmitted. Individual researchers and organizations can decide to send transmissions, and some have. The Beacon in the Galaxy project, proposed in the early 2020s, was a serious scientific proposal to send a detailed information-dense signal. It was not coordinated with any international body. It did not require the consent of humanity as a whole. This is not a criticism of the researchers involved. They are serious people asking legitimate questions. But it illustrates the gap between the potential stakes of these decisions and the governance frameworks we currently have for making them. A number of researchers and institutions have called for exactly this kind of international framework. The SETI Institute has published protocols for what to do if we receive a signal, a standardized approach for verification, reporting, and decision-making. Similar frameworks for active transmission, for METI, are much less developed. This is a policy gap that matters. Whatever you think about the dark forest theory, the decision to broadcast is a decision that affects all of humanity. It shouldn't be made by any single country, organization, or research team unilaterally. It should involve genuine international deliberation, transparent about the risks and uncertainties, accountable to the broadest possible human community. Liu Cixin himself, the author who made the dark forest theory famous, has been asked about his personal views on METI. He has been measured and careful in interviews. He does not claim the dark forest is definitely true. He presents it as a thought experiment, as a disturbing logical possibility that deserves serious attention. He has suggested that if he were advising governments on this question, he would recommend caution, particularly with deliberate, high-power transmissions. There's a particular irony in the situation. The civilizations most likely to survive in a dark forest universe are the ones that shut up the earliest, the ones that broadcast, the ones that try to connect, to communicate, to reach out, are the ones that get found, which means the universe, over long enough timescales, would be increasingly dominated by civilizations that chose silence and concealment over communication, which is, of course, what we observe. A universe full of potential civilizations and silence. The silence is not absence. It's the aftermath of selection pressure. The communicators have been selected against. What remains are the hiders. Let me ask you something. If the dark forest is real, what should we do? There's no obvious answer. We've already announced ourselves. Our signals are out there. There is no taking them back. Whatever is within 200 light years knows we're here. But there are choices about the future, about how much more information we provide, and how deliberately we seek contact. And those choices are worth making consciously, with full awareness of the stakes. The optimistic version of our situation is this: if we are genuinely primitive enough to be ignored, if our current technology makes us look like an ant colony to any civilization watching, then we have time. Time to develop our own capabilities. Time to think carefully about what we want to say and to whom. Time to develop international frameworks for making these decisions. Time to get better at understanding what's actually out there before we invite it to notice us more specifically. The pessimistic version is that we've already done the damage, that any civilization within 200 light years that would respond badly to our presence already knows about us, and that what we do from here doesn't change that. The honest answer is, we don't know which version is true. We don't know if the dark forest is real. We don't know if there are civilizations nearby. We don't know how our signals have been received or what the response, if any, will be. What we know is that the question is serious, that the stakes are real, and that thinking carefully about our electromagnetic presence in the universe is not paranoia. It's prudence. The dark forest theory is disturbing. It's supposed to be. It holds up a mirror to the logic of survival and competition and asks, if this logic applies universally, what does it imply for the universe we observe? And the universe we observe is silent. That silence might mean the dark forest is wrong, that life is simply rare, that civilizations don't survive long enough, that we're looking in the wrong places. Or it might mean the dark forest is right, that the universe is full of hunters in a dark forest, that the ones who made noise are gone, and that we, in our 100 years of electromagnetic broadcasting, have just turned on a very bright light in the middle of a very dark wood. We don't know which it is. But now you do know the argument. You know why some of the most thoughtful people in science take it seriously. And you know why the question of whether humanity should keep broadcasting is not just a scientific question. It's one of the most consequential decisions our civilization will ever make. This is Void Atlas. I'm your host. The dark forest theory is the most unsettling idea in the Fermi Paradox literature, and it deserves to be taken seriously. Not because it's definitely true, but because if it is, and we ignore it, the consequences are irreversible. Be thoughtful. Be curious. And maybe, just maybe, be a little quieter than you would otherwise have been. Subscribe to Void Atlas. New deep dives every week. The universe is enormous and ancient, and possibly full of things that are watching. Until next time, keep your eyes open and your radio transmitter on a low setting. But I'm not done, because there are dimensions of the dark forest theory I haven't explored yet. Dimensions that make it richer, stranger, and ultimately more unsettling than the basic game-theoretic argument alone. Let me tell you about what Liu Cixin actually builds in his Remembrance of Earth's Past trilogy, the 3 novels of which The Dark Forest is the second. Because understanding the full intellectual structure he develops helps clarify what's genuinely novel in his thinking, and what distinguishes it from simpler, aliens are dangerous arguments. The first novel, The Three-Body Problem, introduces a civilization called the Trisolarans, who have detected Earth's signals and are on their way. They sent their fleet around 400 years ago, and it will arrive in approximately 400 more years. They know where we are. We know they're coming. The clock has been started. The second novel, The Dark Forest, is where the theory is fully developed. The main character, a sociologist named Liu Cixin, is tasked with developing a deterrence strategy, a way to protect Earth from the Trisolarans without military confrontation. And through a long process of thinking and living, he arrives at the dark forest solution. The key insight he develops is not just that civilizations are dangerous, it's that civilizations cannot help being dangerous, even if they want to be peaceful. Because as long as resources are finite and growth is inevitable, any civilization is a potential existential threat to any other, given sufficient time. You might be harmless today, but you won't be harmless in a million years if you survive. And because you might survive and grow into a threat, eliminating you now is rational for any civilization that can do so at low enough cost. Luoji's deterrent solution, his cosmic sociology, is to develop the ability to reveal the location of a civilization to the entire universe, a sort of mutual assured destruction at cosmic scale. If Earth is attacked, he can expose the Trisolaran's location to the universe, inviting all other civilizations to strike at them as well. The threat of exposure is what keeps the peace. It's a brilliant and horrifying concept. The weapon is not a bomb or a fleet. It's information, the ability to announce another civilization's location, to paint a target on them. And it works in the novel, precisely because the dark forest logic is universal. Any civilization, anywhere, exposed to any other civilization is in danger. Information is the weapon. Silence is the shield. Liu Cixin is not a physicist by training. He's an electrical engineer who worked for a power plant in China while writing the trilogy. But he draws on deep familiarity with physics, mathematics, and science history. The sociological premises of the dark forest, the two axioms of cosmic civilization, he calls them. Survival is the primary need, and civilization continuously grows while the total matter in the universe remains constant, are presented as almost law-like. Inescapable consequences of physics applied to biology, applied to civilization. He is careful in interviews to distinguish the dark forest as a logical structure from a moral endorsement. He is not saying civilizations should hunt each other. He's saying, given these premises, this is the equilibrium the logic leads to. If you accept the premises, the conclusion follows. And the premises are hard to reject. Now I want to address something important that often gets lost in discussions of the dark forest. The theory has critics, and those critics have legitimate points. The first major criticism is the sustainability objection. The dark forest assumes that civilizations will inevitably grow and require ever more resources. But what if that's not true? What if a sufficiently advanced civilization, one that has existed for millions or billions of years, has found ways to limit its growth, to live sustainably within its resource envelope, to not need more than it has? This is actually a serious objection. On Earth, many societies have maintained relatively stable populations and resource use for extended periods. It's not inconceivable that a civilization could, over long timescales, reach a stable equilibrium that doesn't require constant expansion. If growth is not inevitable, the resource competition premise collapses, and with it, the necessary conclusion that all civilizations are ultimately threats to all others. Liu Cixin's response to this, in the novels, is essentially that sustainability at the civilization level does not guarantee sustainability at the universe level. Even if individual civilizations stabilize their resource use, the sum of many civilizations across billions of years still creates competition at cosmic scales. But this response is less airtight than the original premises. The second major criticism is the communication objection. Could sufficiently advanced civilizations develop reliable methods of verifying intentions? In game theory, the prisoner's dilemma can be resolved if players can make credible commitments. Could interstellar civilizations find ways to make such commitments credible across the vast distances and timescales involved? This is where our ignorance about advanced civilization capabilities is most acute. We can't rule out that a civilization existing for 1 billion years would have developed communication and verification technologies we can't imagine. The dark forest logic is tight for civilizations at our current level of development. It may not apply to civilizations far beyond us. The third criticism, and this one I find genuinely important, is the survivorship bias argument. Liu Cixin presents the dark forest as if it leads to a stable equilibrium, a universe of silent, hiding civilizations. But is that stable? In game theory terms, if all civilizations are hiding, then any civilization that breaks the strategy, that comes out of hiding and starts hunting, gains an advantage over all the others who are still hiding, which means the equilibrium isn't stable. Defectors from the hiding strategy benefit. And over long enough timescales, civilizations that develop aggressive hunting strategies would be selected for. This actually makes the dark forest more dangerous, not less. If active hunting is selected for, the universe wouldn't be populated by cautious hiders. It would eventually be dominated by aggressive hunters. And we've been making ourselves very visible. There's a fourth consideration that I think deserves its own attention: the temporal dimension of the dark forest. One of the most unsettling aspects of the theory is the asymmetry of timescales. From our perspective, 100 years of electromagnetic broadcasting seems like a lot. But from the perspective of a civilization that has existed for 1 billion years, 100 years is nothing. A blink. If there are civilizations within our detection range that are significantly older than us, they have had vastly more time to develop the capabilities to detect, interpret, and respond to our signals. The question is not just whether they know we exist, it's whether, in the context of their billion-year history, our signals register as significant enough to warrant action. A civilization 1 billion years old, looking at a species that has had radio for a century, might reach one of several conclusions. They might decide we're so primitive as to be entirely beneath their notice. They might decide to watch and wait. They might have long since developed policies about how to handle new civilizations. Policies we know nothing about, developed under conditions we can't imagine. Or they might have concluded, a very long time ago, that any new signal is a threat to be eliminated before it can grow. We don't know. We have no way to know. And this is, ultimately, what makes the dark forest theory so unnerving. Not the mechanics of the argument, the premises, the game theory, the conclusions, but the fundamental epistemic situation it describes. We are making decisions, broadcasting decisions, policy decisions, in a state of profound, irreducible ignorance about who might be listening, what they value, and what they would do with the information we're providing. In that state of ignorance, caution is not paranoia. It's the only rational response to asymmetric risk. Let me tell you about some of the specific signals and transmissions humanity has sent, because I think it's worth understanding concretely what we've already done. The most sustained source of electromagnetic emissions from Earth is our radio and television broadcasting, which began in earnest in the 1920s and 30s. These signals are relatively weak. A civilization would need to be within perhaps 20 to 40 light years, and would need instruments comparable to the Arecibo telescope or better to detect our typical television broadcasts. But our military radar is significantly stronger and has been operating since the 1940s. Military radar pulses, particularly the kind used for tracking aircraft and missiles, are more powerful and more artificial looking than our civilian broadcasting. The Arecibo message, transmitted on November 16, 1974, was a deliberate, high-powered transmission aimed at Messier 13, a globular cluster 25,000 light-years away. Its power was about 20 trillion watts equivalent, enormously more powerful than our ordinary broadcasting. It would be detectable by a radio telescope equivalent to Arecibo at a distance of about 6 light-years. Not far by cosmic standards, but enough to reach several nearby star systems. The cosmic call transmissions, sent in 1999 and 2003 from Yevpatoria, were directed at specific nearby stars, including Gliese 777, Gliese 379, and others within 50 light-years. These were more carefully targeted than the Arecibo message, using the more powerful Yevpatoria radar. The teenage message, also from Yevpatoria in 2001, included music and greetings, and was directed towards 6 sun-like stars within 70 light-years. The Cosmic Call 2 in 2003 included messages from individuals around the world and was again directed toward nearby star systems. Each of these transmissions added to the pool of specific, intentional, information-rich signals, moving outward from Earth toward identifiable star systems. Not passive leakage, deliberate communication attempts. The most recent proposals have been even more deliberate. The Beacon in the Galaxy message, developed by a team that included Jonathan Jiang of NASA's Jet Propulsion Laboratory, was a detailed proposal for a comprehensive signal containing mathematical and physical concepts, DNA structure, Earth's location, and human imagery. It was proposed to be sent using FAST, the Chinese 500-meter aperture radio telescope, the most powerful radio telescope in the world, toward the inner Milky Way. The proposal generated significant controversy among the scientific community. Many researchers argued it should not be transmitted without broader international consensus. The debate illustrated exactly the governance vacuum I described earlier. Serious scientists with a serious proposal and no established international framework for deciding whether to proceed. There's something both admirable and troubling about this. The impulse to reach out, to make contact, to answer the question of whether we're alone, is deeply human. It's the same impulse that drives all of science, the desire to know, to connect, to expand what we understand. But desire, however noble, doesn't change the risk calculus. Let me end with something that I think the dark forest theory, whatever its ultimate truth value, teaches us about ourselves and our situation. We are a young civilization, perhaps 200 years old in technological terms, perhaps 10,000 years old if you count from the beginning of recorded history, perhaps 300,000 years if you count from the emergence of anatomically modern humans. In the context of a 13.8 billion-year-old universe, we are extraordinarily new. We are also right now at a particular moment of vulnerability. We have developed enough technology to make ourselves visible, to broadcast across light years, but not enough to defend ourselves against anything capable of crossing interstellar space. We are in the phase where we're detectable, but not yet capable. If the dark forest is real, this is the most dangerous phase. We're visible. We're not strong. We're showing our location to anyone who might be looking. And the window of vulnerability may be long. The development of meaningful interstellar defensive capability, whatever that would even look like, is likely centuries away if it's achievable at all. What can we do? Probably not much about the signals already sent. They're out there. But we can be more thoughtful about what we send in the future. We can develop the international frameworks for making these decisions. We can take the question of our electromagnetic presence in the universe seriously as a matter of policy, not just science. And we can keep asking the question that the dark forest forces us to ask. Not just, are we alone? But, if we're not alone, what does that mean for how we behave? Because the dark forest theory, at its most fundamental level, is not just about aliens. It's about the logic of survival in a competitive universe. And that logic applies here to us, in our own world, in our own choices about how we treat others we don't fully understand, how we manage uncertainty, how we balance openness against prudence. The universe might be a dark forest, or it might be something very different. We don't know yet, but we're in it, and we've been making noise. This is Void Atlas. I'm your host. The dark forest theory is disturbing. It's supposed to be. It asks us to take seriously the possibility that the silence in the sky is the silence of caution, and that we have broken that silence in ways we may not fully understand. Whether it's true or not, the question it asks is real. What do we owe to the universe? And what does the universe owe to us? Subscribe to Void Atlas. New deep dives every week. The questions we're asking are the most important ones humanity has ever faced, and we're going to keep asking them. Until next time, look up, listen, and think carefully about what you say next. One more dimension before we close. Something I haven't addressed yet, that I think is crucial to the full picture. The dark forest theory, as I've presented it, assumes that civilizations are fundamentally similar in their basic drives, that resource competition, survival pressure, and growth are universal constants of intelligent life. But what if they're not? What if the most advanced civilizations have transcended these drives entirely? This is a serious challenge to the dark forest. The theory's logic depends on civilizations being recognizable as competitive agents. But a civilization that has existed for 1 billion years, one that has solved all its energy problems through fusion or Dyson spheres, that has solved death through digital consciousness, that has access to resources on a scale we cannot imagine, might have evolved beyond the kind of competitive, zero-sum thinking that drives the dark forest logic. Such a civilization might genuinely not care about eliminating potential threats. Not because it's naive, but because it's so far beyond any possible threat that the concept of danger doesn't apply to it. The same way that a mature adult human does not experience existential threat from an ant colony. Not because the human is foolish, but because the disparity in capability is simply too vast. In this view, the dark forest might apply to civilizations in certain ranges of development. Those advanced enough to be aware of competitors, but not so advanced as to be beyond competition, but not to the most ancient and powerful civilizations. If this is right, the universe might contain multiple tiers. Young, primitive civilizations like us, who are vulnerable and perhaps don't know it. Middle-tier civilizations, in the dangerous zone where competition still matters and the dark forest logic applies. And elder civilizations, the ones that have existed for billions of years, who have passed through that zone and come out the other side into something we can't conceive of. The question then becomes, which tier are our potential neighbors in? And that question, of course, we have no way to answer. There's another possibility that Liu Cixin explores in the third novel of his trilogy, Death's End, a possibility even more disturbing than the dark forest itself. The idea that civilizations don't just eliminate each other, but can reduce the dimensionality of space, can drop regions of the universe from 3 spatial dimensions to 2, can collapse entire star systems into tiny, dark, 2-dimensional objects. This is not a serious physics proposal. It's science fiction at its most speculative. But it illustrates the endpoint of the escalation logic the dark forest sets in motion. If elimination is the universal strategy, civilizations will develop ever more comprehensive and efficient means of elimination. And the endgame of that escalation might be weapons that don't just destroy civilizations, but alter the fabric of space-time itself. The universe we would end up in at the end of that process is a very different place from the one we currently inhabit. Much of Liu Cixin's work explores these implications, not as predictions, but as warnings about where certain logical trajectories lead. It's worth noting that Liu Cixin has said in interviews that he is not pessimistic about humanity's future. He believes the dark forest describes a possible configuration of the universe, not a certain one. He is hopeful that intelligent civilizations can find ways to establish trust and cooperation, even across interstellar distances. But he thinks that hope should be informed by clear-eyed analysis of the risks, not blind optimism. That's a useful model for how to hold the dark forest theory. Not as certain doom, not as paranoid fantasy, but as a rigorous analysis of a possible configuration, worth understanding and taking seriously, even if we hope it's wrong. Let me leave you with a thought about what the dark forest theory means for the long arc of human civilization, if we take it seriously. We are young, we are noisy, we are visible, and we are at the beginning of a trajectory that will, if we survive, take us to technological capabilities we can't currently imagine. The question the dark forest poses for that trajectory is, can we grow up fast enough? Can we develop the wisdom, the governance, the self-restraint, and the capability to navigate a universe that may be fundamentally competitive before we run into something that would prefer we didn't? The answer is not written. We don't know how much time we have, or whether time is what we're short of. We don't know if the nearest potential threat is 10 light years away or 10,000. We don't know if our signals have already triggered some response that is currently traveling toward us at a fraction of the speed of light. What we know is that we are here, now, with choices to make, about what to broadcast and what not to broadcast, about how to develop our technology and our governance, about whether to take seriously the possibility that the universe contains forces we don't understand and can't yet handle. Taking the dark forest seriously is not defeatism. It's not a reason to despair or to stop trying to make contact or to stop exploring. It's a reason to be thoughtful, to be careful, to recognize that some decisions are irreversible and should be made with appropriate gravity. We are, after all, a species that built nuclear weapons before we had the wisdom to manage them safely. We developed social media before we understood its effects on democracy and mental health. We released industrial chemicals into the atmosphere before we understood the greenhouse effect. We have a consistent history of developing powerful technologies faster than we develop the wisdom to use them well. The question of our electromagnetic footprint in the universe deserves better than that pattern. It deserves serious international deliberation, transparent risk assessment, and decisions made with the long-term future of humanity explicitly in view, not in the back room of a research group, not unilaterally, not by accident. This is Void Atlas. I'm your host, signing off on what I hope has been one of the most genuinely thought-provoking videos we've made together. The dark forest theory is a mirror. It shows us the logic of survival in a competitive universe and asks us to look at what that logic implies for our situation. Whether the forest is real or not, the question it poses is real. What do we do with the knowledge that we might not be alone and that not all company is welcome? There are no easy answers, but there are better and worse ways to ask the question. And asking it clearly, understanding the argument, the objections, the uncertainties, is the beginning of asking it well. Subscribe to Void Atlas. We'll keep asking the hard questions every week, for as long as the stars keep burning and we keep looking up at them. Until next time, stay curious, stay thoughtful, and maybe, just maybe, stay a little quieter than you otherwise would have been. The forest is dark. We're in it. What we do next matters. There's one final thread I want to pull before we're truly done. A thread that connects the dark forest directly to something happening right now, in real time, in the world of radio astronomy and space policy. In the early 2020s, China's FAST telescope, the 500-meter aperture spherical radio telescope, became the most powerful radio telescope on Earth. Built in a natural depression in Guizhou province, it has a collecting area roughly twice that of the former Arecibo telescope, which collapsed in 2020. FAST can detect signals from much greater distances with much better sensitivity than any previous instrument. And China has been using FAST for SETI searches. In 2022, Chinese researchers announced that FAST had detected several anomalous narrow-band radio signals that warranted further investigation. The announcement was initially covered by Science and Technology Daily before being taken down. A curious sequence that generated significant attention before the researchers clarified that the signals were almost certainly radio frequency interference from terrestrial sources. But the episode illustrated something important. China's investment in SETI is serious. FAST is a real instrument with real sensitivity. And as China's space program continues to grow, with lunar missions, Mars missions, and ambitious plans for deep space exploration, the question of how China approaches the question of METI, of active broadcasting, becomes increasingly relevant. This matters for the dark forest specifically because Liu Cixin is Chinese, and the dark forest theory has cultural resonance in China. Chinese discussions of space policy and SETI are not separate from the cultural context that produced the most developed fictional treatment of the dark forest. This doesn't mean Chinese space policy is shaped by a novel. Of course not. But it does mean that when Chinese scientists and policymakers think about these questions, they're doing so in a cultural context that takes the dark forest logic seriously as a thought experiment. The international dimension of METI policy is not just about governance structures. It's about the fact that different countries, with different cultural frameworks and different levels of investment in radio astronomy and space exploration, are making independent decisions that affect all of humanity. This is another reason why the development of international frameworks, forums where these decisions can be made collectively, with input from scientists, philosophers, policymakers, and the public, is urgent. Not because any specific transmission is necessarily dangerous, but because the cumulative effect of many independent decisions about broadcasting, made by many countries and organizations without coordination, could be significant. The history of nuclear weapons offers a cautionary parallel. The development of nuclear technology was initially the province of a small number of scientists and governments. Over time, it spread. The frameworks for managing nuclear weapons, the Nuclear Non-Proliferation Treaty, the International Atomic Energy Agency, bilateral arms control agreements, developed after the technology did, in response to the reality of its existence. They have been imperfect, but they have so far prevented nuclear war. Something analogous might be needed for METI. Not a prohibition, that's probably unenforceable and possibly undesirable, but a framework for deliberation, consultation, and shared decision-making about how humanity presents itself to the universe. The stakes, if the dark forest is real, are somewhat higher than nuclear war. Nuclear war would be catastrophic, but it would not necessarily be the end of the species. An encounter with a civilization that has decided our existence is inconvenient might be. I don't say this to terrify. I say it to make clear why the governance question is not abstract. It's one of the most concrete policy questions humanity faces as it enters the space age, and we are entering the space age more rapidly than most people realize. The commercial launch industry has transformed access to orbit. Lunar missions are planned by multiple countries. Mars missions are on the horizon. The development of technologies that would make interstellar communications significantly more powerful. The proposed Breakthrough Starshot project, which aims to send small spacecraft to Alpha Centauri using powerful lasers, would also, as a side effect, create a laser system with enormous potential for directed METI, are underway. The window for deliberate, thoughtful decision-making about humanity's electromagnetic presence is not infinite. It's open now, and it's worth using it. Liu Cixin's Dark Forest, in the end, is not a counsel of despair. It's a call for seriousness, for recognizing that the universe is not necessarily arranged for human convenience, that the silence in the sky demands explanation, and that the most disturbing explanations deserve the most careful attention precisely because, if they're true and we ignore them, we can't undo our mistake. We can survive the dark forest, if it exists, but only if we take it seriously enough to behave appropriately, to be careful with our signals, to develop our capabilities, to build the international frameworks that allow humanity to make collective decisions about collective risks, to take seriously the possibility that we are not alone, and to prepare ourselves for what that means, in all the directions it might mean it. The forest may be dark, we may be deep in it, we may have already made our presence known, but we're still here, and that means we still have choices. Make them carefully. This has been Void Atlas. I'm your host. Thank you for spending this time with me in the dark. Every week we come here and we look at the hard things, the questions that don't have comfortable answers, that demand serious engagement, that connect the deepest science to the most immediate human concerns. The dark forest is one of those questions. It might be the most important one. Subscribe to Void Atlas. Come back next week. The universe is waiting, quietly, as always. Until next time.